Alright, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 Programming or C# Programming Fundamentals class, I've been going over a series of video presentations I'm creating based off of the book that we'll be using for the class, that book being Murock's C# 2015. The book has 26 chapters, and so far I've gone through all of Section 1, so the first 3 chapters. So it's time to start on Section 2, Chapter 4, How to Work with Numeric and String Data. And I am going to do that literally right now, but I just wanted to mention to you, I'm going to grab my Chapter 2 invoice total. I'm going to right mouse click on the folder, choose Copy, right mouse click again, and choose Paste. And it makes a copy, and I'm going to change this to Chapter 4 invoice total and remove the copy from it. Now, this will work just fine. I'm not going to have any problems, but I will tell you that it's sort of not the best way to do it, because notice when I double click on this, it still has Chapter 2 invoice total. I'll live with that, okay? So I'm going to open this. Why? Just in case I want to demonstrate some of the stuff that's shown in the chapter, I'll be able to do so in the guise or in the context of using it with this program. All right, so this is the same program. Still works, but it's the Chapter 4 version, so to speak. So it's 250, hit enter, boom, everything's cool. Or was it 250? It was 225. And there we go. All right, so clear, exit. Yes, I want to exit. Just a couple very minor changes. Okay. First is I want to come in here and, yeah, it says invoice total. But I want to just change the text to invoice total Chapter 4. Didn't have to do that. I didn't put in 2 and 3 on the first one, but I've got that in here now. So let's jump into the book and look at the slides here. Again, it's going to be my way that I'm not going to sit there and when they have these objectives, I'm not going to read them to you. I'll leave them up there for a second and you can look at them yourselves. But we're talking math. We're talking arithmetic in this chapter. You'll notice when they talk about variables, we already have. We'll get into constants in this chapter as well. All right, we've already looked a little at toString. All right, here are the built-in, what are called value types in the next 3 slides that are available in this language. The first one is type byte. Byte, in my opinion, for whatever that is or is not worth, it's kind of an underutilized variable type. Notice it has a range from 0 to 255. It'd be ideal for something, for example, like age. Now I realize that with a person's age, they can't, I mean 130 would be really pushing it. But it's not bad. Still, byte is very rarely used. Not only is there a byte, there is a signed byte. So instead of having a range from 0 to 255, a signed byte has a range from -128 to +127. Then there's a short, which has got an integer, or this is a whole number. Notice int, 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 those are all whole numbers. In fact, so are bytes. But the short has a range, all right? If it's signed, you don't say S short, you just say short. It's got a range from -32,768 to +32,767. If you put a U there, meaning it's unsigned, meaning it can only have positive numbers, then it goes from 0 to 65,535. Then you'll notice with a 32-bit integer, same kind of thing, but it's -2,147,000,000 $483,648 to positive $2,147,483,647, or an unsigned, which goes from 0 to positive 4 billion plus. All right, then there's a long, I can't read that number because I don't know what it means. All right, it's bigger than anything I've ever encountered, and you can do it signed or unsigned. Then you've got floats and doubles. All right, those are numbers that can have a decimal place. Now you'll notice I didn't use those, and neither did the author earlier. The author used decimal because that is actually a more concise and precise answer that you get than you do with floats and doubles. Decimal, again, we've already talked about. There's a char for a single character, and bool, which is true and false. All right. How to declare and initialize variables. You can do it as two different statements or as one statement. Start the names of your variables with a lowercase. Capitalize each letter that follows. What does that mean? That means we've been doing it right. First name, lowercase, uppercase, last name, etc. So what we've been doing so far has been good. Okay? One thing we have not put in here so far that I'm going to add right now, and that is we're going to put in some program constants. Like what? Well, I'm going to have here const, which says it's a constant, and I'm going to put in here decimal. Whoops. And I'm going to put min hours, and that's the minimum number of hours you can work in a week. Well, let's set that equal to 0. Back 0m. And then we'll have another const, decimal, and we'll have max hours. And that'll be equal to 84.0 m. All right, then we're going to have another const, decimal. How about min hourly rate? We're going to set that equal to 0m. And a const, decimal, max hourly rate. Let's say that we decide that no one can make more than $250 an hour. All right, just pull that number out of the air. Finally, let's see. Let's put in a couple more things. So first, let's have in here we'll put in here another decimal, max non-OT hours. So that's the most numbers you can work without getting overtime. That'll be 40. Oh, what else do we want? Let's just say for now that's okay. All right? So I'm going to put here minimum hours for employee per week. All right, so we're assuming you can't work a negative number of hours, and that would make sense to me. This would be the maximum. So you don't work more than like 80 hours, 84 hours in a week. That's 12 hours a day, so that seems to make sense. So this would be minimum hourly rate for employee per week. And this would be maximum hourly rate per employee per week. And then finally, this would be minimum non-overtime hours per week. So when you create a constant, which means that throughout the value of this program, the value of this constant cannot change. We may not use it yet in this, any of these yet in this chapter, but that's okay. Again, I can be real anal here and line everything up. Actually, one more. See that? Do you have to do that? No. Does it make the program work any better? No. Does it make the program work any worse? No. But if you're really into lining stuff up, and I usually am, all right, you can do that. All right. So the word const for a program constant followed by the type of variable. All of these are decimal. And then typically it's convention to put the name of the constant in uppercase to symbolize that you cannot change its value once it's been set. And again, I tried to come in here and come up with, notice I've got 0.0. I could have put here 0.0. I could have put here 0.0. Here we could have put in 0.0. And here we could have put in 0.0. Would have all worked just fine doing that. Do you have to? No. Should you? Matter of personal choice. So the name again in uppercase equals and the value that will be assigned to that. All right? Okay. I think that all looks pretty good. I've already shown you these, okay, and talked about what they are. Notice with a char in single quotes. With a Boolean, it only has a value of true or false. I hate this. Int x equals 0, comma, y equals 0. I say put on one line int x equals 0, semicolon. On the next line, int y equals 0, semicolon. Yes, it's a little more typing, but variables don't get, quote, lost, unquote, then. So here was the constant. The author doesn't do it the way that I do it. He just capitalizes the first letter. I capitalize every letter. Why? Because that's the way I was taught. All right? Arithmetic operators, you should know the first 4 by now. Plus for addition, minus for subtraction, asterisk for multiplication, and / for division. All right, modulus is the remainder operator, so it's what's left over. If I take 13 and divide it by 3, it goes in 4 times with 1 left over. So 13% sine 3, or 13 modulo 3, would be equal to 1. Typically, it's used for dollars and cents, hours, minutes, and seconds, etc. Plus for a positive sign, minus for a negative sign. You can use plus plus or minus minus if you want to add 1 or subtract 1 from something. We'll get into that more as we go on. Here's some examples. There's shortcut operators. What does that mean? That means that if I am going to sit there and say this, if I'm going to put in here x equals x plus 7, I can type that just like that. Or I can say x plus equals 7. So if I want to add 1 to a number, there's 4 ways I can do it. I can say x equals x plus 1, which is probably the worst way of doing it. Or I can say x plus equals 1, and as you can see, there's less typing. Or I can say x plus plus, or I can say plus plus x. All 4 of those will do the same thing. And on here, if instead of adding I wanted to subtract, I can say x minus equals 7 to multiply x times equals 7 to divide x divided by equals 7, just 1. And finally, for modulus, x modulo equals 7. Okay? I can only use the plus plus or its other one, the minus minus, if I want to either add or subtract 1 from a value. So you, for instance, you cannot come in here and say minus minus x, 7. That doesn't make any sense. All right. And they give examples. I've already shown you some, how you can use these. The order of precedence for arithmetic operators, you actually should have learned this back in your days of, I don't know, maybe junior high school. Okay? The auto increment and the auto decrement, the plus plus or the minus minus, is done first. Then a plus or a minus sign. Then you do multiplication and division and modulo before you do addition and subtraction, unless you want to change that with the use of parentheses. Now here, they show the difference between the plus plus before the variable, etc. Notice A is 5 and B is 5. When you do this, this means add 1 to A, which means it's 6, and then assign 6 to Y, so they're both 6. When you put the plus plus on the end, it says take whatever is in B, which is 5, assign it to Z, so B and Z are both 5, then add 1 to B, which means B is 6, but Z is still 5. All right? Casting gets a little bit confusing, all right, but I want you to understand it, so to show it to you, if I come through there, I'll just move down here. And I say int number 1 equals 13. Int number 2 equals 6. Int result equals number 1 divided by number 2. Well, that's going to say 13 divided by 6. 2 and 1 6. But since you're putting it into an integer, the result of this is going to be 2. So what if I say fine, float or double, result 2 equals number 1 divided by number 2. What about then? And it's smart enough to say, oh, you're putting the result in a float, but you're dividing an integer by an integer. So this one will give you 2.0. If I do want to make sure that it's 2 and 1 6, then either I do one of these three things. So if I want it to be 2.166667, for example, all right, instead of 2.0. That one is 2.0. Then I can either say float, this is called a cast, or I can say float, or I can say float. It's a little overkill, but it'll work also. So in all of those last three cases that are in there, I'm doing casting. Here I'm casting before the first value, here before the second, and here I'm casting before both the first and the second. All right? So that's what they talk about here on slide 20. The math class has a bunch of built-in stuff. What does that mean? Well, the easiest way to not even explain it, but rather kind of to show this to you, all right, in my humble opinion, the easier way of doing this is to come in here and, we could go through a bunch of examples with this stuff. So in other words, what if, in this example here, you saw that it was 2, okay? But what I can do is I can say take this and math.round and then tell it to round this. And you might say, big deal. Who cares? Well, if this is 5, 13 divided by 5 is 2 with a remainder of 3. If I tell it to round this, all right, if I tell it to round it, it's going to round up because it's going to be 2.6 is the answer. So if I tell it to round, I can tell it how many decimal places I want it to round to. Since I didn't put any in here, it'll round up. So instead of 2.6, it'll give you an answer of 3. But if I do this, all right, like this, even though it's still 2.6, it won't round it. So I can use the math class in different operations, like round for rounding. Pow is what you use instead of, to put something to a certain power. So for instance, if I wanted to do 3 times 3, in fact, let's just use this one. Oops. If I come through here and say int result equals math.pow 13 2, it's going to give me the answer of 169, which is 13 times 13. So this is another way of saying 13 times 13. If I put that in there, it would be 13 times 13 times 13, and whatever that is. Okay? Where am I for time? Oh, way over. All right, that's the end of this one. Pick it up in the next one.